Since December 2019, the COVID-19 outbreak caused by SARS-CoV-2 has led over 164,622,565 of confirmed cases and over 3,411,080 deaths. 143,525,870 of recovered cases worldwide as of May 18, 2021. The main transmission routes of SARS-CoV-2 indicate that this respiratory disease can spread by inhalation. Hi, I am Jiezel Andrada, and in this video, we will talk about intermolecular forces and the ways that relate these with the spread of today's coronavirus pandemic. But before everything else, let us first know, how can coronavirus be transmitted?
Transmission of SARS-CoV-2 occurs via droplet transmission, contact transmission, and aerosol transmission. Droplet transmission occurs when respiratory droplets produced when an infected person coughs or sneezes are inhaled by a person nearby. Contact transmission occurs when a person touches a contaminated surface and then their mouth, nose, or eyes. Aerosol transmission occurs when respiratory droplets containing the virus mix into the air and are then inhaled. COVID-19 is stable for up to 24 hours on cardboard, 2 to 3 days on plastic and stainless steel, and up to 3 hours in aerosols, which include fog, mist, dust, air pollutants, and smoke. Therefore, it is possible to get infected by touching contaminated objects or through the air.
So what is intermolecular force? How does it relate to COVID-19 transmission?
Molecular interactions, and these are the forces of attraction that act between molecules. These are non-bonded interactions, unlike our ionic and covalent bonds. They do not involve the transfer of any of electrons. They are a result of the constant and random movement of electrons within shells of atoms. There are three main types of intermolecular forces. The first is London forces, the second is permanent dipole interactions, and the third are hydrogen bonds.
Now let us discuss the relationship between intermolecular forces and the spread of coronavirus disease. Or have you already figured that out? We'll see. COVID-19 is a contagious disease, as we all know, and its contagion has something to do with intermolecular forces. Coronavirus is not only transmitted through a direct contact with droplets of infected people, but as well as indirect contact with contaminated surfaces that carry respiratory droplets from infected persons. Have you ever wondered what causes COVID-19 contaminate these surfaces? The corona-like component of the outer surface of the SARS-CoV-2 variant, named spike protein, is the key target for the absorption and persistence of SARS-CoV-2 on various surfaces. It is the component responsible for contaminating the surfaces of inanimate substrates due to its ability to assemble into crown-like nanoarchitecture that allows the viral binding and fusion to host cell membranes through molecular recognition. Here is a diagram showing schematic of SARS-CoV-2 variants in respiratory droplets contaminating solid substrates such as glass, metals, plastics, and fabrics, and the zoomed-in structure of the SARS-CoV-2 variant. To systematically investigate the adsorption behavior and interaction mechanism of COVID-19 spike protein, herein a direct and quantitative analysis of surface interactions of spike protein was presented with respect to adsorption, kinetics, and intermolecular forces in the nanonewton range. In these two diagrams, it have systematically quantified the intermolecular interactions between spike protein, the corona-like component of the SARS-CoV-2 variant, and a series of inanimate surfaces in which the contamination of these surfaces impacts the rapid increase of new coronavirus disease transmission. I hope I was able to successfully share my learning with you guys and that you have learned something about intermolecular forces, awareness of COVID-19 outbreak, and its ways of transmission. So that's it, and please stay safe, everyone.